In this video, we will prove size induction. Size induction is a theorem that says for every type x with a size function f, and for every predicate p on x, we know p holds for every element x if we know p holds for x whenever it holds for all y smaller than x. So let x be a type, f be a function from x to nat, and p be a predicate on x. While there are no special assumptions about f, the idea is it gives the size of the elements of x. We will say y is smaller than x if f of y is less than f of x. Assume we know p holds for x whenever it holds for all y smaller than x. Let little x be an element of type big X. We need to prove px. Note that our single assumption gives us a way of proving px. So we apply the assumption, and now we need to prove for all y smaller than x, py. Clearly, it's enough to prove the more general statement for all n and y. If fy is less than n, then py. We can prove this by induction on n. This leaves us with two cases. In the base case, we assume f of y is less than 0, and we need to prove py. Since no natural number is less than 0, this case is impossible, and we are done. In the inductive case, we assume as inductive hypothesis that for all y, f of y less than n implies py, and we let y be given and assume f of y is less than the successor of n. Now we need to prove py. We can apply our original assumption again to reduce the claim to proving for all z smaller than y, pz. Let z smaller than y be given. Now we need to prove pz. Using the inductive hypothesis with z, we can reduce the claim to proving f of z is less than n. Since f of z is less than f of y, which is less than n plus 1, we know fz is less than n, as desired. And so we're done.